Welcome to the deep dive. This is where we take the topics and the source materials you send us and really try to understand what's going on with them.
And today, we're diving into something from the world of RC cars, specifically the control processing receiver, the CPR unit.
That's right. We got some great info from a listener who was curious about these things. Why were they so popular for a time and then, well, where did they go?
So our mission today is basically to trace the life story of these CPR units, understand the appeal, and then figure out the reasons behind their disappearance.
Think of it as a quick way to get up to speed on a really interesting piece of RC history.
Yeah, it's sort of a classic tech story, isn't it? That tension between making things simple by combining them versus needing specialized bits for better performance.
Definitely. And just to set the scene, think about those early RC cars. You had wires everywhere, right? Connecting the receiver, this big mechanical speed controller, sometimes even a separate battery just for the radio gear. It was messy.
And as the CPR unit promised to fix all that, clean it all up.
Exactly. So let's get into it. What exactly was a CPR unit?
Okay, so fundamentally, the CPR unit was an early stab at integrating electronics in RC. It combined the radio receiver, the part that listens to your controller, with the electronic speed controller, the ESC, which handles the motor.
Ah, okay. So combining the car's ears and its throttle control into one box.
That's a pretty good way to put it, yeah.
Huh.
And CPR stood for Control Processing Receiver.
Yeah.
They were mainly aimed at 110th and 112th scale cars, which were, super popular.
Yeah, right.
But the idea itself was flexible. You could, in theory, use them in boats or maybe even some small planes.
Interesting. So what were the key parts inside one of these CPR units? What made it tick?
Well, you had the receiver part, obviously picking up the signals for steering and throttle.
Okay.
Then the ESC section. Now, this was a big step up. They sometimes called it things like amplifier-boosted electronic rate control or similar terms. It managed power to the motor forward, brake, sometimes reverse.
And this used FETs, right? Not like the old clunky resistors.
Exactly. Field effect transistors. They allowed for pulsed power delivery. Think of it like tapping the power on and off really fast to control speed, instead of just burning off excess power as heat, like the old mechanical speed controllers or MSCs. Much more efficient. Gotcha. Much smoother control, too, I bet. What else was in there?
They also squeezed in a battery eliminator circuit, a BEC. This was clever. It let the receiver and the steering servo run off the main 7.2-volt motor battery, stepping the voltage down.
Oh, right. So you didn't need a separate little battery pack just for the radio gear.
Precisely. Even if it wasn't always explicitly labeled BEC, that function was usually built in. And you also had the power switch integrated right onto the unit. Simpler wiring again.
Okay. And you mentioned something about split servo functionality. What's that about?
So split servo probably referred to the fact that the CPR provided the control logic, the signals, and the regulated power from the BEC for an external steering servo. The servo itself, the bit with the motor and gears that actually turns the wheels, was still separate. Right, the CPR was just handling the brain and power side for the steering. Makes sense. So who is the big name behind these? Which company really pushed CPR units?
Oh, that was definitely Tamiya. They were the major player. They really embraced the CPR concept and featured them heavily.
Tamiya, yeah, that figures. They were huge. Can you give us some examples? Like, what different CPR units did they make?
Sure. If you go back to maybe 1987 or so, you had the CPR unit P100F. They showed up in famous kits like the Thundershot and the Avante.
Oh, yeah, classics.
And it could handle brush motors down to about 17 turns. The 100 likely meant around 100 amps continuous current.
Okay.
Then, pretty soon after, came the P160F, beefier. That one could handle hotter motors down to 12 turns. Rated at 160 amps continuous with a pretty massive peak, like 640 amps. That was Tamiya item 45015.
Wow, 160 amps continuous back then was serious business. What about less extreme options?
Yeah, they had the P80F too. More of an entry-level or standard option, designed for motors around 23 turns or higher. Probably 80 amps continuous, based on the name. And later, you saw the CPR's 01. This was more basic, often found in their ready-to-run XB models, like the TT01 chassis cars. Aimed at standard 27-turn motors, cost-optimized, even used simpler spade connectors for the motor instead of bullets.
Right, for the beginner market.
And they even had specialized ones for their smaller Tamtec line, like the P05DB.
So it sounds like they had a whole range. And the naming, the P number, that directly related to the power handling.
Exactly. P80F, P100F, P160F, and that told you the continuous amps. It created clear tiers for performance and, price. Very straightforward for the customer.
Yeah, that's helpful.
And seeing those specialized units like the CPR 01 for ready-to-run models or the Tamtec ones, it really shows how that integration was useful for simplifying things, especially in pre-built cars or tight spaces.
And they started as upgrades, right? Hop-ups.
Yeah. Initially, you'd buy them separately to upgrade your car. Then later, Tamiya started including them in the box, especially with those XP ready-to-run kits. It shows the tech becoming more mainstream.
Okay, so we know what they were, and Tamiya was key, but why were they so popular? What was the big appeal during their heyday?
Well, several things really clicked. The biggest one was just how much better they were than the old mechanical speed controllers.
Right, the MSCs.
MSCs were, frankly, pretty crude. They wasted a ton of energy as heat, and you only got step speeds like maybe 3 speeds forward and 1 reverse. Very jerky.
Yeah, not very precise.
CPR units, using those ECTs and electronic pulses, gave you smooth, proportional control, much finer speed adjustments. This meant the car was easier to drive and your battery lasted longer too. We found a user quote saying, "They are excellent things, battery lasts a lot longer, and it's much more user-friendly." That drivability and efficiency, a huge deal.
Better control, longer run times. Yeah, I can see the appeal there. What else?
Simplicity and tidiness. Fewer wires, less clutter inside the car. Combining the receiver and ESC just made for a neater installation.
Okay, cleaner build.
And potentially more reliable. Fewer connection points to fail. Plus, saving space became important as chassis designs got more complex or compact. Someone mentioned needing a CPR for a Tamiya Top Force because there just wasn't much room for separate bits. Another user said they look great and tidied the wiring up dramatically.
So form and function, tidier and potentially more reliable. And Tamiya pushing them must have helped too.
Oh, absolutely. Tamiya's strategy was key.
Right.
They often bundled CPR units with their ad-spec radio sets, making it an easy package deal.
Ah, the ecosystem approach.
Exactly. And their kit manuals for huge sellers like the Thundershot, Avante, Hornet, they often specifically recommended or were designed around using a Tamiya CPR unit. It locked people into the Tamiya system, built brand loyalty. The manuals really centered the CPR.
Makes sense. They made it the default choice.
And that move from being just an optional hop-up part to being included in the ready-to-run XP kits was massive. It made the hobby more accessible. Less intimidating for beginners if the main electronics were already combined and installed. More plug and play.
Okay, so they had a good run. They improved things, simplified builds, Tamiya backed them, but obviously they didn't last. Why did CPR units eventually fade away?
Yeah, their decline really came down to a mix of their own built-in limitations and just being overtaken by rapid progress in other parts of RC tech, like radios and motors.
All right, let's unpack that. What were some of those inherent problems people started running into?
Well, performance-wise, braking was often a sore spot. We saw comments describing the brakes as terrible or having this weird tendency to magically apply themselves.
Oh, unpredictable brakes. That's not good.
No, definitely not. One user called it their biggest gripe. So inconsistent, unreliable braking was a major issue for anyone wanting better control. Calibration could also be tricky.
How so?
The early P100F, for instance, apparently lacked internal calibration settings. You had to rely purely on tweaking your transmitter trims, which could be, finicky and not super precise.
Right, a bit hit or miss.
And the reverse function was usually pretty basic, often just a single, quite slow speed. Some described it as kind of weak, not always enough power or speed to be really useful, especially compared to what standalone ESCs started offering.
So some fundamental performance niggles. What about coping with newer tech, like different batteries?
That became a really big problem. When LiPo batteries started becoming popular lithium polymer, they could deliver current much more aggressively than the old NEM-H packs.
Right, more punch.
And the overcurrent protection in many CPR units just wasn't designed for that. It could trip unexpectedly, even with motors that ran fine on NEM-H. They weren't robust enough for the new battery chemistry.
Ah, okay. Couldn't handle the power surge.
Similar issue with motors. As people pushed for more speed with lower turn, more powerful brushed motors, those motors drew more current than many CPR units could safely handle. They'd overheat, shut down. They just hit their limits.
So they were being outpaced by both battery and motor evolution.
Exactly. And then there was the fundamental issue of integration itself. Because everything was in one box. If one part failed, say, the receiver component died, the whole unit was useless.
You couldn't just replace the broken bit.
Nope. And replacing the whole CPR unit could be, as one person put it, stupidly expensive, even back then.
Yeah.
Or if one part just became outdated, like the ESC couldn't handle the motors you wanted to run, you were stuck. No upgrading just the ESC or just the receiver. That lack of modularity was a killer blow as technology moved faster.
Yeah. Being locked into that single unit became a major disadvantage. Okay, so inherent limits. What about external factors? You mentioned radios.
Yes, the radio revolution, the shift to 2.4 gigahertz was absolutely massive.
Yeah.
Most CPR units use the older AM or FM radio frequencies. Remember crystals?
Oh, yeah, swapping crystals, hoping nobody else is on your channel.
Right. And those systems were prone to interference. 2.4 gigahertz tech, with things like frequency hopping, FHSS, was just vastly superior. No more crystals, you just digitally bind your transmitter to your receiver. Much smaller antennas. And, crucially, way better at rejecting interference, so tons of people could run cars at the same time without issues.
That was a huge improvement for usability.
Game-changing. And because the AM/FM receiver was baked into the CPR unit, these integrated units essentially became obsolete almost overnight from a radio perspective. You couldn't separate the receiver to upgrade it.
So the radio part was instantly outdated.
Plus, standalone 2.4 gigahertz receivers quickly became tiny and feature-rich, which kind of eroded that original space-saving argument for the CPR, especially compared to the bulky old AM/FM receiver sections. The priority shifted heavily towards having a reliable radio link.
Okay, so the radio tech left them behind. What about motors? You mentioned brushed motors earlier, but wasn't there another big shift?
Absolutely, the rise of brushless motors.
Yeah.
CPR units were designed only for traditional brushed DC motors.
Right.
Brushless motors work completely differently. They need an ESC that can do electronic commutation, basically, sending precisely timed pulses of power down 3 wires to create a rotating magnetic field. It's more like AC power in a way.
So totally incompatible with the 2-wire DC output from a CPR's brushed ESC section.
Totally incompatible. As the saying goes, hook up a brushless motor to a brushed ESC and nothing happens. Or nothing good, anyway. The timing isn't there.
And brushless motors brought big advantages.
Huge advantages. More power for their size, way more efficient, less maintenance because there are no physical brushes to wear out, and generally longer lasting.
So better performance across the board.
Pretty much. As brushless tech got more affordable and became the standard for performance-oriented RC, CPR units became completely irrelevant to that whole, rapidly growing part of the market. You simply couldn't use them with the new motor technology. It really shows the danger of integrating things when key components are evolving down different paths.
So radios changed, motors changed fundamentally. Anything else pushing CPRs out?
Yeah. The final nail in the coffin, really, was the development of much more advanced standalone ESCs and just a general shift in the hobby towards liking modular systems.
Okay, so separate ESCs got much better.
Way better. And fast. Standalone ESCs started offering vastly increased power handling, sophisticated programming options. You could tweak throttle curves, braking strength, motor timing, set low-voltage cutoffs for lipos, all that stuff.
Much more tunable.
Exactly. Plus features like telemetry feedback, stronger BEC circuits, specialized designs for racing or crawling, things the integrated CPRs just couldn't match.
And people liked being able to mix and match.
Definitely. Hobbyists increasingly wanted the freedom to pick the best receiver for their radio, the best ESC for their motor and battery, the best servo. You could upgrade one piece at a time, replace just what broke. Even Tamiya started supplying separate ESCs, like their TEU 101BK, in kits instead of CPRs.
Right, they moved away from their own integrated solution.
That modular approach was just more flexible, often more affordable for upgrades or repairs, and allowed for way more optimization. The fixed, all-in-one nature of the CPR just seemed limited and outdated in comparison.
So the market basically voted for flexibility and peak performance over that initial simplicity of integration.
That's a good way to put it. The desire to customize, to get the best performance, and to future-proof their setups really pushed the hobby towards modular components.
Okay, so wrapping this up, the CPR unit, it was definitely innovative for its time, simplified things, improved on the old MSCs, made the hobby more accessible.
For sure, a really clever bit of engineering for its day.
But ultimately, it just couldn't keep up. Overtaken by huge leaps in radio tech, the brushless motor revolution, and this drive towards powerful, programmable, standalone electronics.
Yeah, the integration that was once its strength became its weakness. It got locked out by progress on too many fronts.
It's a really neat case study, though, isn't it? That whole tension between making something simple and integrated versus making it modular and high performance.
It really is. You can see that pattern play out in lots of tech areas.
Yeah.
And, you know, while CPRs themselves are gone from mainstream RC, the idea of making things user-friendly, especially for beginners, that legacy lives on in today's ready-to-run packages.
Yeah, the goal of easy entry is still there. And it's just a cool reminder of how fast tech moves. What was cutting edge then is history now. So what happened to all the old CPR units? Just landfill?
Oh no, not at all. They've actually become quite collectible. For vintage RC enthusiasts doing period-correct restorations of cars from the 80s and early 90s, finding a working Tamiya CPR unit, especially the P100F or P160F, is a big deal.
Ah, so they're sought-after historical pieces now.
Exactly. Apparently, even back in the early 2000s, they were considered stupidly expensive to replace if you could find one. So they have real value to collectors preserving that era of RC.
From high-tech hop-up to vintage collectible, quite the journey.
It really is. But it leaves you thinking, where else have we seen this happen? Integrated solutions. They were popular for a while, but eventually gave way to more specialized modular approaches as technology evolved. What might be the CPR unit equivalent in some other field today? Something to ponder.